Hello everyone. In this particular video, we are going to cover some design principles in ER modeling. Of course, I should certainly mention this that the list that I'm going to cover today, certainly it's not comprehensive in the sense that there's so many things that you need to consider. But nevertheless, I'm going to give you some examples and give you some guiding principles to avoid design errors. Okay. So first and foremost, your design, whatever you're making, should be faithful in the sense that it should reflect the reality, right? So for example, if you were designing this movie schema, then it makes sense for the relationship between stars and movies. It should be many to many, right? It's common sense in some sense, right? Right. And similarly, let's say there are two entities in an academic system. One is instructors or teachers and the other one being course. So if you are considering relationship between them, it should be many to many, because an instructor can teach several courses, and similarly the same course can be taught by multiple instructors and all that, right? And but these are the easy ones, but there are some more complicated things. So for example, what if a course can have multiple sections? What if there is a concept of instructor in charge, or if you want to maintain history. So all in all, what I want to say is that when you are designing the schema, try to think about the business logic as thoroughly as possible. Of course, we all understand that despite having a very good design in the beginning, as you start your implementation, and then when you deliver the project to your client, something or the other always comes up. The client will say that, okay, maybe this thing should also be done, or maybe you may forget uh, to ponder about certain things during the design. Those things happen, but nevertheless, put in a genuine effort in capturing as many concepts as possible in the design phase itself, right? Okay. Next, yeah, again a very basic thing. When you're designing tables, you should avoid redundancy as much as possible. So for example, in this case, let's say that for sake of argument, I'll say that this studio relation, do we really need to have it as a separate entity, or can the studio be inside movies, right? uh, so now you can immediately say that this will create redundancy, because now the address of the studios will appear in every tuple of the movies. If we get rid of this particular entity, and then put all the details in this by putting more attributes here only, then you're going to create redundancy. For example, the address of the studio will get copied several times, one for each tuple where that studio appears. And also there is also a risk of update anomaly. So for example, if the address of the studio changes, then you have to change the address of that particular studio in all the tuple where it appears, right? So all in all, it's not a good idea to have this entity as attributes over here, right? So just to illustrate, right, that you should avoid redundancy in your schema, right? We should be very careful in putting the data in its absolute right place. If you keep copies of the data, then you will always have this problem of updation, right? When you update one copy, you have to update the other copy also, and so forth, right? So as much as possible, avoid redundancy. Sometimes some real time systems, where speed is of greater importance, uh, there are known cases where data redundancy is maintained, but that's a whole different ball game. How much redundancy, and then there are specific protocols on what is the amount of redundancy that you maintain, how many updates are allowed, and so forth. But just keep it in mind that too much redundancy, if if it is not affecting your performance, then have as less redundancy in data as possible. Right? Second, simplicity always matters, right? The more complicated your design, the more number of tables, triggers, and this and that, the more complicated your design, the more possible it is to land into a situations where there are unintended bugs in your system. Right? So the simplicity always counts. So here is a small example which I picked up from your textbook. So let's say that you have these entities, movies and studios, and movies are owned by studios. So for sake of argument, let's say that I create this another entity called as holdings, where each movie kind of represents one holding, right? So see, this is a one-to-one relationship. That means one movie is functional. One movie implies one holding, and then several holdings can be owned by the same studio. It's a many to one relationship from holdings to studios. Now if you see this, right, you can immediately make out that holdings was absolutely not necessary, right? Because by making it one to one, I'm implying that one movie is equal to one holding and vice versa, right? So when this is there, right, uh, right, it essentially means that I could have written movies only itself, movies here itself, right? So this holdings relation was absolutely useless. It is not giving any extra value. I could delete all of this and just create a many to one relationship from movies to studios. This relationship will catch everything which these three together will catch. Okay, so simplicity counts. Do not complicate things too much, right? Again, set of guidelines, so to say, that as I said before, have the right set of relationships, right? Having too many relationships may sometimes lead to redundancy, update anomalies, or delete anomalies, right? Uh, so just be wise in deciding what are your relations. Too few of them will not be able to catch a whole lot of your business logic. Too many relationships can complicate things. So try to have a right balance. Okay, so just an small example in this. So for example, you know so on just see the ER diagram on the left and right, right? So in the ER diagram on the left, the same three entities are there in both these. So you have actors here, studios here, movies here, and then similarly over here also you have actors, studios, and movies. But on the left side, what I have done is I am joining actors and movies via this relationship called as stars in, and I'm joining movies and studios via this relationship called as owns, right? So that means it's a many to one from movies to studios. That means several movies over here can be owned by the same studio, and actors and movies, it's a many to one relationship, right? So now, so this is one schema, or one design. On the right, what I have done is that I have basically deleted both these, and then I'm putting just one relationship, which is a multi-way relation between all these three entity sets. Actors, movies, and studios are now joined by contracts. Now the ultimate question over here is that uh, is this better than this or not, right? So in your project schema also, when you're designing that, right, uh, I think probably as soon as this diagram module is done, I'll put out the project specification. It's already prepared. You should spend at least 2 weeks on brainstorming the design, right? So when you are brainstorming that design, I would want you to reflect all these things which I'm covering here. You have to ask this question to yourself. Am I going with the best design possible, or can I improve it? what kind of business logics can be captured, what cannot be captured, and if it cannot be captured, what kind of triggers are you required to write, to capture all the business constraints, right? So I hope you remember this, that triggers are a classical way of capturing all the business constraints which cannot be encoded in the design itself, right? Okay, so now coming back to this example, we were comparing whether this is better or this is better, right? Let's see, the slides are pretty good, so you can just click through, but nevertheless, I'll go through them, right? So the first thing is that if a star can appear in a movie if and only if there is a contract which involves that star, right? So that means a star cannot work in a movie until and unless there is an contract. If there is a condition like that, then this guy is pretty good, right? Then this contract will have that contract, and this stars in relation is no longer needed. Okay. Okay. Now let us see the second part. Okay. Now, so in the previous slide, we decided that the stars in relation is not needed if there is a constraint that a an actor can work in a movie if and only if there is a concept of a contract, and that contract is owned by a studio, right? Because movies by itself is, it's just a product. The studio, as the he's the one who actually holds the the legal documents of the movie, right? So under that condition, the stars in relation, anything that it can capture, this contracts will basically capture everything which this can capture. Now let's come to own. So here it's a bit tricky. So uh, so for us to have something over here, remember that when this contracts relation is converted into a table, then what will happen is that this the tuples of the contract relationship will basically take primary keys from the stars entity, the movies entity, and the studios entity. And for having sanity, we'll make sure that everywhere the foreign keys are in place, right? Now if something like this is there, then what will happen? The primary key of the contracts table will be the combination of movies and stars, right? Now uh, now let's assume that there is a case where the studio has already made decided to produce a movie, right? But it has not signed up any contract with any of the actors, right? So for example, our contracts may also even have some component of money involved. It's logical to assume that, right? So now if a studio has movies in place, but it has not signed up with any of the actors, then having a thing over here, it will have a lot of null values. Okay. Right? Now that is not a good idea. So in that special case where the studio is already owning the movie, but there is no actor which has been signed up, in that case you need to have this owns relationship. But otherwise, contracts is good enough to connect all these three entities. Okay. Let's see more. Okay, so in the next three slides, again, they are closely following your textbook. Uh, what we are arguing here is that so we have this ER diagram, and we are arguing if all of this needs to be a separate entity, or can it form a part of the movies itself. right? But as we agreed, this is not a good idea, because of all the update anomalies that it will get. For example, if the address is changed for studio, then you have to keep changing it for all the tuples, right? So your textbook writes these things formally. I would want you to just go through them, rather than if I keep reading all of this, it will become very boring. Okay. Okay, so these, as I said, these three slides, you should read them carefully. Okay, next set. In the next few slides, I'm going to cover about the keys. I think I have already covered this concept quick in multiple places, but nevertheless, I'll just cover it quickly here one more time. So as I said, a super key of an entity set is the set of one or more attributes which uniquely determine the entity, right? A candidate key is an super key which is of minimal in size, and an entity set can have multiple candidate keys. You pick one and make it the primary key. Okay, so the same thing follows here also. And for when you are converting relationships into tables, means when you are considering relationship sets, as I said before, the combination of the primary keys of the participating entity set forms the super key, right? But then, depending on what kind of cardinality constraints or things are there. So for example, uh, when there is a many to one relationship, right? So then the whole thing does not become the primary key. Just to give you an example, let's go back. Okay, so here when you are converting this contracts relationship set into a table, attribute wise, yes, I agree, it will take the primary key from here, here, and here, right? And obviously, those three will form a super key. But in terms of candidate key, given that we have this bold arrow here, that which means that it's a many to one relationship from stars and movies to studios, right? Under this constraint, what can happen is that when you convert this diamond into an table, your primary key would can be, or your candidate key can be just the combinations of the primary key from here and here, right? So just two attributes are enough to have the primary key, right? So note that stars and movies will have their own primary keys. I'm talking about the table which comes when you convert this diamond relationship into an table, right? So that table, it will have three attributes which are basically primary keys of all the participating entity sets, right? Out of those primary keys, when you decide the primary key of this entire table, then I'm saying that the key which is coming from the actors and the key which is coming from the movies, they both together can uniquely identify a tuple because of this many to one relationship going on here. Okay, so that is what is written, right? Okay. Okay. Couple of slides on converting ER diagrams to relational schemas. Okay. Uh, See, again, I think I have told this multiple times, but nevertheless, for sake of, as I said before, there are two simple rules. So we turn each entity set, the rectangles, into a relation with all the attributes, and we will put the primary key by drawing a bold line under the attribute which forms the primary key for you. And then each diamonds, each which represent so basically, as you know, diamonds represent relationship, and each relationship is also converted into a table whose attributes are basically the keys which are coming from the connecting entity sets, right? And if the relationship has attributes, then they also become the attributes, right? So I think these two thumb rules I covered previously also. The thing to note is that sometimes we may want to combine relations. I'll give you an example. And another thing is that this concept of weak entities, right? We will cover this later as we go forward. I'll immediately give you an example of this guy first. Okay. So basically, we can combine relations when there is some kind of an many to one relationship going on. Okay, let's see how that can be done. Okay. So let me show you an example of a case where relation when tables created can get absorbed. Okay, this is a good example. Okay, so I'm just using this particular example for illustration, right? So here we have entities of movies and studios. They both are there, and movies are owned by studios. Okay, and then when you just focus on this part, right? So if you go with the thumb rules which I covered, what will happen? This rectangle which will get converted into a table, and that table will have all these four attributes. This rectangle will also get converted into a table, and it will have these two attributes. And then this diamond owns relation will also get converted into a table, and the attributes of this guy would be what? The key attribute, or candidate key from the studios table, probably studio name, that will form an attribute in this table. And it will also pull in whatever is the key attribute of the movies entity. So I think maybe title or title and year, if there are duplicate names. So then when you convert this into a table, it will take three attributes: studio name and title and year, right? And if there were any other attributes for this relationship itself, like start date or release date or something, they will also form, right? So this is how the table for the owns relationship set will look like, right? Now what happens is that if you see this closely, uh, owns is an many to one relationship from movies to studios. Okay. Now uh, the candidate key, or the primary key of the movies, right? Let's say title and year, right? So given that title and year is the candidate key, it can uniquely determine the length and genre of that particular movie, right? So that is the definition of primary key. And by the virtue of the owns relation being a many to one relationship from movies to the studios, conceptually speaking, the title and year of any particular movie can also uniquely determine the studio name, right? Because and we are saying this because there is a bold arrow which is coming here, right? So the primary key of the movies table can functionally determine or can uniquely identify the corresponding studio name also, right? And it can also identify the uh, whatever attributes which are here, right? What was the release date and all that, because it makes sense, right? Let's say there was a movie Titanic, right? Titanic was owned by some studio, right? So the Titan, if you have the primary key of that movie Titanic, it will immediately tell you its length and genre and year of release. And just by knowing the name of the Titanic, it makes sense that you can also know the studio which produced Titanic, right? Because we have a many to one relationship from the movies to studios. And if there were any attribute sitting over here, even they can also be functionally determined by the movie. So for example, if there was an attribute over here called as movie budget, right? uh, right? So for a movie, the owns one, it's conceivable to have an attribute over here called as budget of the movie. Now if I have the name of the movie, or whatever is the primary key of the movie, I can determine the budget also, right? The movie title can uniquely determine what was its budget, right? So the moral, to summarize, what happens is when we have a setting like this, and that includes any attributes over here, right, where I have a many to one relationship going from here to here, then what happens is that the primary key of this particular relation can functionally determine or can uniquely identify the primary key over here, the participating primary key from this guy, and also any attributes which can come here. So under that cases, what happens is that it is okay to delete the table corresponding to the owns relation and introduce extra attributes over here, right? And those attributes, what would be those attributes? One attribute would be the whatever is the key over here, you'll put it over here, right? Of course, you'll put foreign key constraint and all that, that's fine. And any other attribute which was sitting over here. So for example, if there was an attribute over here called was amount signed or something like that, that can also come over here only, right? So the moral of the story is that whenever you have many to one relationships, you can get away by deleting the table corresponding to the diamond, uh, which is involved in the many to one relationship. You cannot do that with star sim, right? It's a many to many relationship. You can never get away by not creating a table for this guy, but you can get away by not creating a table for this guy. But in that case, you have to take the key attribute over here and place it on this side also. Remember that that is not really duplication, because even if you had created this relation, the primary key of studios would have come anyways, right? So that is not really data duplication. Okay, I think your textbook also writes this very carefully, right? I think you should read this. Okay, so this slide just sort of summarizes what I just covered. Okay, okay, so I'll stop this video for now. All right, hopefully you got an idea on how to be little careful while designing the schema, and how to set keys, how to avoid creating unnecessary tables. Okay, so I think more of this will come into picture when you start working on your course project. Okay, I'll stop here for now.